Hello, everybody. How's everybody doing today? I'll give it a couple minutes for everybody to join the class since it's going live a little bit earlier than usual. So how is everyone doing today? I'm excited. This is my second lesson, so I think we're going to have a good time. This one's going to be a little bit longer. I've planned it to be about an hour and 30 minutes. And of course, the recording will always be available on teach.tv. So let's see. It's 11:59 right now. I'll give it 2 more minutes, and then we'll go ahead and get started. And of course, if you're new here, my name is Rune. On TikTok, I go by Blue Hand Coding. This is my first time, streaming on Teach, so really excited. Hello, everybody. How is everyone doing? Maria, Jin, Krish, how are you guys doing? That's good to hear, man. That's good to hear. I'm doing good. As always, I'm excited to be here. It's going to be a good hour and a half. I have everything planned out right here, and it should be pretty interesting. It's going to be a little bit more than what we did last time, so I'm not sure if we'll get through all of it, but that's fine. We'll get through as much as we can, but this should be an interesting class. This is where things will start to slowly, come together a little bit better. Okay, 1 more minute, and then we'll go ahead and get started. Okay, that is 12:02 then, so let's go ahead and get started. So, again, my name is Rune Patel, Blue Hand Coding on TikTok. If this is the first time you're joining us, welcome. I teach programming here on teach.tv. And for those of you guys who are returning, this sort of interface should look pretty familiar to you guys. We went over this last class rather. This is the Repple.it platform where we'll be doing all of our programming in the beginning stages. So I'm actually going to go ahead and load up the Repple from our first lesson, so we can go ahead and just do a quick review of what we covered then. So last class, we talked about print statements. If you remember correctly, we started off with a hello world on this REPL site, and if we ran that in our console, we would get the output. I also talked about how it doesn't have to be double quotes with your print statements. You can also use single quotes, like so, hello world. And running that would also give you the same exact output. So this sort of thing is more of a matter of preference than convention. We also talked about, we talked about the double and single quotes. We also talked about variables, one of the most powerful thing in programming, the ability to set a variable to a specific value and then use that variable later on within the context of your code. So if I remember correctly, I think we had, it was like a naming thing. So we started off with name is equal to Arun Patel. So let's look at the syntax to create a variable. So I've declared the variable's name as name, and I'm basically just setting it equal to this string value. That was the string data type that we talked about. Cool. So then we were like, okay, I have this name variable. How do I use it within my code? So then that gave way to our addition syntax, our fstring syntax, and our comma syntax. So let's just do a really quick review of that. So for the addition syntax, it was something along the lines of my name is. We had that placeholder, right? We took that placeholder and we just added in the variable. So running this should give us the output of my name is Varun Patel. And that's exactly what it does. This was the addition syntax. Then we had our f-string syntax. So the first step with creating an f-string, put the f before your quotes. So that tells Python, hey, this is an f-string. I want you to format it for me. So then with the f-string, we had my name is with our placeholder. And then we just took that placeholder and replaced it with our variable. This should also give us the output of my name is Varun Patel. Finally, our last sort of syntax to print with variables and strings on one go was that comma syntax. So with the comma syntax, we were actually just splitting it into two different things that were printed. And it would add that space there for us. Notice how that space doesn't have to be there, unlike with these two. If we run that, those are all of the same thing. Cool. So we've gone over our addition syntax, f-string, and our comma syntax. So after that, we talked a little bit, just really briefly, about how you name your variables. Again, variables have special rules with when you're naming them. So a variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can only contain alphanumeric characters and underscores, so A through Z, 0 through 9. You can have special, characters and stuff like that within your variable name. And then we also talked about convention with naming your variables. So let's say I want to create a variable that contains my age, right? There's a bunch of ways you can create them. You could say my age is equal to 17. Say my age with that capital A is equal to 17. You say my underscore age is equal to 17. I don't recommend this. It's hard to read. Notice how these two sort of cut up the words within my age into two things which are easily readable. We talked about how this is called camel case. So you have like the camel's back, how it humps. And then you have snake case. Again, this was one of those, preference things. Whichever one you prefer, you can use. And then we did a really, really brief intro into our integers and our floating point, or our floats rather. So yeah, so going back to the age variable, we had that 17, and I think we did something along the lines of taking that age and then adding 1 to it, which printed out 18. So we did a really quick sort of overview of that. And then with our floating point, we did something along the lines of pi is equal to 3.14159. And so we can tell that this floating point is a floating point, it's a float, and not an integer because of the presence of this decimal point. This decimal point is what lets us know that this is a float and not an integer. And then the last thing we covered last class, so I guess we covered a lot of things last class, were the str and int functions. So let's create age as a variable, but this time, instead of making it an integer, let's make it a string, 17. I then showed you guys that if I wanted to print out the age plus 1, which, would give us 18, get an error. That error is a concatenation error, because one of these things is a string, the other one is an integer. So it's like taking a sentence and then trying to add a number to it and then getting a mathematical sort of answer. That makes no sense. So how do we take this age and make it into something that you can actually add with? We had that int function. If I run that, it should give 18. And then the str function was just like if you have an integer, then you can convert it into a string. So that's just about everything we covered last class. And yeah, we talked about all of these as well. So before I continued, does anyone have any questions about what we covered last class? Because if not, we can go ahead and get started with today's class. Okay. Krish asked, do you use the GitHub student benefits if you have them for coding? I actually know exactly what you're talking about, but I haven't used them yet. I'm saving it up for something that I would actually need it for. Right now, I do all my hosting and everything on my own sort of servers, so I'd have no need to use that right now. Okay, so it looks like nobody has any questions. So I've gone ahead and I've created another REPL. And if you don't remember how to do that, of course, you go to this little, these 3 lines, and you should be able to create a new REPL. Make sure you're using Python as your language, and you can name it whatever you want to. So cool. I'm in my new REPL. I have a couple of things here for the rest of class. So what is the first thing we're going to talk about? Today, the first thing we're talking about is something called comments. So if you were quick last class, you may have noticed me. I think we were printing something out, and I had this hashtag, and I wrote, prints hello to console. I think I did something like that. And then I quickly took that away because I didn't want to confuse you guys. So this is what is in programming called a comment. So, programmers write code for computers, but they also write code for other programmers. One of the biggest things with programming is maintaining your code, so that it's able to work along the way. And one of the things that goes in hand with maintaining your code is writing good documentation for your code. So let's say this is the first time I'm looking at this code, and I don't know what print hello does. This comment gives me some clues. It's going to print hello to the console. And so comments help you and other developers understand what is going on in the context of your code in plain text. And if I run this, you'll notice that this doesn't do anything. These comments are sort of ignored by Python. It just lets them sit there so that when you or another developer opens the file, you guys know what you're looking at. So again, I cannot stop stressing the importance of writing comments in your code. And for the context of this course, I'm going to be using comments just to sort of like print what we're doing at that time. So if you ever get lost and you want to scrub back through the video, you can use the comments to tell you what we're doing. So that's just really brief. And for the rest of this lesson, I'm actually going to continue commenting out all the code so you guys can get a good idea of what good comments should look like. Cool. With that aside, let's go back with the integer and float stuff that we were doing from last class. So right now, we're going to talk about something called mathematical operators. Mathematical operators, you know them: addition, subtraction, division, multiplication, your exponents, your floor division, your modulus. A couple of these may look a little bit unfamiliar, but we'll touch on all of them. The most common, of course, you'll know: addition, subtraction, division, multiplication. Math and the ability for a computer to do math is extremely powerful. And that's why mathematical operators are so important. Okay, so you may notice that this addition sign, we use that with our strings, and we use that to sort of combine the strings together. With integers and floating, that's just for normal adding. We use our addition to do normal addition. There's no like special thing that goes with it. So let's go ahead and let's go through all of these just to make sure we know what we're doing. So with our addition, we could do 4 plus 5. Boom, we get 9. We know how that works. With our subtraction, we can do 4 minus 5. Should give us a -1. And we have our division. So we should do 4 divided by 4, which would give us 1. Now, you'll notice here, when I did this addition and subtraction, I got an integer. We know this is an integer because, well, there's no decimal point. However, when I did division, I had a floating point returned to me. Why is that? Why is it that when I divide two integers, by the way, I get a float as my response? Well, think about division in general. If I divided two whole numbers like 5 and 4, I would get an integer value. So it defaults to returning an integer value, or sorry, a float value, even when you can express the answer as an integer, if that sort of makes sense. Cool. And then we have our multiplication. So in normal math, you'll probably know multiplication to be that X or that dot in the middle. With programming, we actually use this asterisk. So it's shift 8. And it should look like that. So you do 4 times 5, we should get 20. Perfect. And then we have addition, subtraction, division, multiplication, and then we have exponents. This is to raise something to a specific power. So a simple example of this would be 2 to the power of 2. And this should give us 4. 2 to the power of 3 would in turn give us 8. And in case you don't know how exponents work, this is basically saying, let me take the number 2, and then multiply it by itself 3 times. So we have 3 2s, so that's where this 3 comes from. And then we have this 2, which is the number that's being multiplied by itself. So 2 times 2 is 4, 4 times 2 is 8. Hence, 2 to the third power is 8. So that's the exponents. These last two are actually a little bit weird. They may be a little bit new to you guys. So this first one right here is called floor division. And so here, let's say I have 13 and I want to divide that by 2, right? It should give us 6.5, okay? But then if I do 13 floor divided by 2, double slash floor division, I get 6, okay? So floor division is basically telling you how many times you can fit a certain number, a whole number, within another number. So I can fit 2 whole times. Sorry, I can fit the number 2 6 full times within the number 13. So it's like the 6 in the 6.5. And then we have our modulus. Modulus is sort of like the remainder. If I do 13 modulus 2, I should get 1. Because what this is saying is if I do 13 divided by 2, right, I can fit 6 in there, right? That's 2 times 6. 2 times 6 is equal to 12, right? But I still have 1 left. So that's what that modulus operator tells you. How many would be left if you fully divide this number into this number? Okay, so that's our introduction into mathematical operators. So does anyone have any questions? Because I know I kind of went over it really, really quickly. And if there's any of them you want me to go over, like I'm pretty sure the floor division or the modulus one may be a little bit confusing. But if not, we can go ahead and move on. Okay, the last two. All right, let's focus on them then. I'll get these out of here. Cool. We're going to go over floor division and modulus. Again, we'll continue. Actually, I'll use a different example. So we don't have to work with the same numbers over and over. Let's see. We'll do 19 divided by 3. 19 divided by 3. Let's see Actually, let's do divided by 4. Let's see what we get when we do that. So cool. 19 divided by 4 gives us the answer of 4.75. And so what this is saying is that if I multiply 4 times this 4.75, I should get that 19, right? 4.75, that 19. So in order for, it's basically saying how many times can the number 4 fit into the number 19? Well, the number 4 can fit into the number 19 4.75 times. Okay? But then, oh, it looks like I've lost connection. There we go. But then, if I want to find the number of whole times, right, the whole number 4, because basically what this is saying is if I want 4 to fit into 19, I'm going to do 4 plus 4 plus 4 plus 4 plus 4. So that's 4 whole times, right? And then this 0.75, that's plus 3, right? Because 75%, or sorry, 3/4 of 4 is 3. And this 8, 16, that all adds up to 19. So when we do our modulus, or sorry, our floor division, we want to see how many times can 4 fit as a whole number without it being, made smaller. We could see that 4 times it'll fit. See? And then our modulus is going to tell us, okay, if I do 19 divided by 4, what will be my remainder, right? What will be the thing that isn't able to wholly divide into that 19? And if you look at this sort of addition thing that we've going on right here, you'd see that 3 is the odd one out. It'd be wise to say that 3 would be the remainder. And if you do sort of, if you're familiar with long division, right, you have your 4, you have that little curve thing, and then you have the 19. 4 is able to fit 4 full times into 19. So then you have 19 minus 16, you're left with that remainder of 3. Okay, cool. And yeah, I actually, these numbers were not that great, to be honest, but I'm glad it makes sense now. But yeah, you can sort of think of these two in terms of like long division, and use that to sort of guide you with how you do that. Cool. So now we have talked about mathematical operators. Let's actually build something with them. So we're going to make a simple program that is going to take my age, it takes my age, and tells me how many years until I'm 100. I'm 100. Okay? So let's use what we've learned, right? So let's just really quickly have all these operators written down. So we have addition, subtraction, division, multiplication, our exponent, our floor division, and then our modulus operator. Let's think about this. We want to make a simple program that takes my age, right? So I'm thinking we're going to have a variable that contains my age and tells me how many years until I'm 100. Okay, so let's start with what we need. We're going to need a variable called age, right? And I'm 17 right now, so we'll hard code that variable right now. And I want it to tell me how many years until I'm 100. Okay, so how about we create another variable, right? And we'll use a mathematical operator to determine how many years until I'm actually 100. So I'll be using my camel case, but of course snake case and whatever convention you want to use also works. So I'll say years till 100. Okay, so that's my variable. And we'll say it's equal to 100 minus 17, minus age, right? So I made a program that tells my age. It also calculates how many years till I'm 100. So let's print this out now, okay? Print. You will be 100 in placeholder years. Well, we have 3 ways to sort of put our variable in there, we have our addition syntax, we have our f strings, and then we have our comma. You guys know I hate the addition syntax. It is so clunky. And I love f strings. So we're going to go ahead and do that. So you will be 100 in what variable am I using? Years till 100. So years till 100. What should we get with this? Boom. You will be 183 years. And of course, if I change it up a little and make it 19, the subtraction thing will tell what it is. The only way I can see this breaking is if you're older than 100, in which case that doesn't really make sense. But that's fine. I don't think anyone watching is over the age of 100. So cool. That's a simple little program we made. Obviously, I encourage you guys to remix it, change it. How about years to your 200, years to your 50, stuff like that. Or you could be like, it'll be this year in, XYZ years. Cool. So we've used our subtraction thing. Let's use one of these little uncommon ones, because I'm pretty sure everyone is fairly comfortable using addition, subtraction, division, multiplication in your exponents. But these last two are probably unfamiliar. Let's try one more thing with our mathematical operators before we move on. Now we're going to so this could be a little bit more complicated, but we'll walk through it together. So we're going to make a game, not a game, we'll make a program that is going to help us determine how many eggs we need to bake a cake. So make a program where you have X amount of eggs and you need Y amount of eggs in total. We need to be able to determine how many cakes can we make and how many eggs would be left. Cool. We're going to make a program where we have X number of eggs. So let's start that. We're going to call it my eggs, right? And we'll just say I have 10 eggs, right? And you need Y amount of eggs to make a cake. So let's say in order to make one cake, we need 3 eggs. We'll say eggs for cake. And this value tells us how many eggs will we need for one cake. You have 10 eggs. Each cake calls for 3 eggs. How many cakes can we make then? Okay. So these are the two we're working with. Which one will tell us the whole amount of times that the number 3, or the amount of eggs for cake, can fit within the amount of eggs we have? Well, that would be our floor division. So if we do by eggs, or divide that by eggs for cake, we see that we get 3. So with 10 eggs, we can make 3 cakes, given that each cake calls for 3 eggs, right? So that answers our first question. How many cakes can we make? We can make 3. How many eggs would be left then? Well, that's where our modulus operator comes into play. So again, let's just write the same thing. It's the same thing, my eggs. But instead of using floor division, we're going to use our modulus operator to determine how many eggs would be left after we do that sort of division. Eggs for cake. And if you sort of connected the dots, then we should get 1, right? Because think about it. This tells us how many cakes we can make, right? We can make 3 cakes. Each cake is 3 eggs. 3 times 3 is 9. That's 9 eggs. That means we have 1 left. So yeah. Anyone have any questions with that? Or would you guys like me to do another sort of project example with, the different operators? Okay. I'm not seeing any questions. But again, stop me whenever you guys need to. I'd be happy to go back and talk about our mathematical operators later on. So cool. We have our mathematical operators down. And I just want to take this time to, of course, encourage you guys after class or whenever to take what you've learned or what we've gone over in that day's lesson and sort of implement it in your own code, write your own code, practice writing your own code. And of course, even with what I do here with the stream, try remixing the code. So, you could say, how many cakes could I make if each cake called for 4 eggs? Use that to sort of build a stronger understanding and a stronger foundation with Python. So cool. We have gone over our mathematical operators. Now we're going to talk about something that I think you guys have been wanting to do. And that is, how do we add our own input into a function, into a program rather? So, you guys might be confused. You're saying, well, we can just change all of the variables, right? And then we can use that to, make the program more dynamic. That's not that fun. What if we could have a way to, in our console, directly type in whatever, and then whatever we type gets saved into a variable? That means every time we run the program, we get a different output. So let's do that. And to introduce that, we have our input function. Our input function. And as the name says, this is the way that you guys can give input into the program, where user input through the keyboard and the console can be injected into the code. Okay, so let's create an example really quickly. We'll say name. We'll use our name one again. This is like the best one there is. Input. What is your name? I'm just going to write the code out really quickly, and then I'm going to go ahead and explain it. Gotta have those placeholders. What are we looking at here? Well, this bottom part probably looks really familiar to you guys. But what about this right here? Name is equal to input. What is your name? Let's run this. You'll see that I ran it, but you didn't immediately get this whole print statement, right? Usually when we ran our code, we would immediately have the entire thing execute. But we're waiting at this prompt. What is your name? And that sort of is the same thing that we typed in this input, in those inner braces, or parentheses. What is your name? And then that's the prompt that we're given in our console. All right, I'll type my name in, Varun Patel. And I'm going to go ahead and press enter. It says, hey, your name is Varun Patel. Wasn't that cool? So that means if I run it again, I can give myself another name. So I can say Blue Hand Coding. And then that prints out as well. You guys might be beginning to see how awesome it is that now you can give your input, and it makes the program so much more interactive. So again, let's go over what this input function is doing, right? So we know what a function looks like, right? You have the name of the function, input, and then you have these little brackets, parentheses. And inside this parenthesis, we're putting what is your name. So this, what you put inside the input function, is basically just like the prompt that is going to be given to your user. And then from there, they can type in whatever they do, and then that is then saved to the name variable. So again, input function, whatever goes inside the parentheses is the prompt that is presented to the user. Whatever the user then goes ahead and types is then saved to the variable, which in this case is name. And then we can print that out or do whatever with it. A thing I would like to note with the input function is that no matter what you type, even if it's a number, it'll always get saved as a string. So saved as a string. So does that make sense? And of course, we're going to build with this. We're going to make our own little code with it. But I just want to make sure that you guys understand what I'm doing right now. Okay. Can we have more examples? Yeah, of course. So we'll touch a little bit about this whole string thing later on. So let's do something else. What is your name? We can just ask, what is your age again? And then we can segue that into dealing with this. So your age is age. So this is sort of the same thing I had last time. Oops. Let me make sure I actually name my variables the right thing. We run that, we get 18. Again, let me go over what's going on here. Input, right? That's telling us that we want to take input from the user. Whatever goes inside these parentheses, right? That's sort of like the prompt. So you see how we're prompted to type our age in right here. That's exactly what's within our those parentheses. And then whatever we type, right? I've typed in this 18. It's then saved to this age variable. So you're basically saying age is equal to whatever input the user gives. So first, this input is determined, right? And then it's saved to that age variable. So what's essentially going on, right, is it's Python is basically breaking this down into things. So we start with this, right? Age is equal to input. What is your age? This eventually turns into this, in our case at least, because we're typing in that 18 right there. So what is the result of this? Well, it's the result of what the user types in, which is 18, and then that is then saved to our age variable, and then that's referenced later on in our code. So does that sort of, connect the dots a little bit better? Okay, perfect. Perfect. Cool. So we've gotten our age down. Let's make something more interesting with this. Let's continue with this age example, actually. And again, we're gonna build upon that last thing that we just did, where it tells us how many years until you're 100, right? Let's make it what we had last time. So we had like age is equal to 17, years till 100 is equal to 100 minus age, and we print you will be 100 in years to 100 years. We forget not to format that. All right, we know what this will do, right? Okay, but what if I want to make this a little bit more dynamic? I want to take user input on this. Well, what is the thing that we actually need to change in this code? We want to make this part more dynamic, the age that we're setting. So what if I made this the input? What is your age? And then I would type in that 17, and then, yada, 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 yada. It would do everything that we expect it to do. And of course, I want to mention that the input function saves things as strings. So you guys could probably tell what might go wrong here. But I'm going to go ahead and run the code anyway. It's going to ask me, what is my age? Well, I am 17. Unsupported. Oh, we got an error. It says type error. Unsupported operand type for subtraction, int and string. So what this type error is telling me is, hey, you're trying to do something that shouldn't make sense. You're trying to subtract between an integer and a string. An integer and a string. Well, guys, what do we do if we have a string and then we want to turn that into an integer? What is the function that we can call to sort of to fix this issue that we are getting? Yeah, int, the int function. It's like the best thing ever. Okay, so if I wrap this in the int function, right? So we're saying, hey, this age, which is a string, we're going to make it an integer. So now you're subtracting two integers. And that makes sense, right? That's something you can actually do. If I run that, 17, hey, it'll be 183 years. I can run that again. I can make it whatever I want to. I'll be 40. I'll be 160 years. So it's much more fun than just going back and changing the same variable over and over and over and over. So you'll notice that I wrapped the age variable in the int function right here, right? When we're doing our subtraction, but you could also put it right here. That might look a little bit confusing. So it's like I have a function, and then I have a function inside of a function. Well, if I run this, does it still work? Let's try it out. What is my age? Well, I'll be 23. It still works. So let's take a look at what's going on here. This is a function, and this is a function. So I'm basically giving a function to a function. But here's how Python sees it. Basically, this turns into this. So let's say I give it the input of 18. We're starting at the innermost, right? And then working our way out. So let's say I typed in 18, right? That's going to be a string. And then you're basically calling the int function on that. So once you do that, you then get this integer of 18. So that's sort of the progression of how this whole thing turns into this. Now, what do I encourage? Right, because we had two options. We could either put the int function here, or we could put it here. Honestly, both of them work. Again, this is one of those personal preference things that you sort of have to deal with. Personally, I like this nicer because you're not chaining those functions. Therefore, it's not that confusing to look at. Because again, the number one thing with programming and writing code is making sure that it's readable. That is the number one thing that you guys should be thinking of. So cool. We've chained together a lot of things we've learned. We've used the input function. We've used a little bit of those mathematical operators. We've used those int functions, and then we've used that string f-string notation that we touched on the earlier. So any questions with this? Or should we go ahead and build another mini project to sort of solidify what we've learned? Okay. Well, I'm not seeing any questions, but again, always ask. I'm ready to answer. So let's build something a little bit bigger. Because again, the best way to learn, especially with programming, is to practice, 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 but also build, build, build. So what is our next project going to be? Well, let's make a simple addition calculator. Okay. We're going to take two numbers, we're going to add them together, and then we're going to print out the result of those numbers. So first, let's get a general idea of what we're going to have. We're going to have two numbers, right? And we want the user to give those numbers to us. So we're going to have two numbers, we're going to add them together, and then we're going to get our output, and we're going to print that out. Okay? So we'll have create two variables. We'll call first number, then we'll have second number. Again, we're going to want the user to give us these numbers. So we're going to use that input function, right? And so what prompt should we give them? Well, with the first number, we can say, type in your first number. And then with our second number's prompt, we could just say, type in your second number. Cool. If we run that, looks like it's loading. Looks like Repple is acting up. While that figures itself, actually, I'm going to go ahead and reload. Hopefully that'll fix the issue. There we go. Type in your first number. We'll say it's 10. Type in your second number. We'll say it's 4. Nothing happens, but we're not getting any errors, so we're on the right track. Cool. And then we're going to print out their sum. That's pretty easy. You just take your first number, and then you add your second number to it. Cool. Then we're going to print out the sum of the two numbers is sum. I keep forgetting to format the string, but there we go. So before we go ahead and run this, I want you guys to take a look at this and tell me if you think there's anything that could go wrong. You remember what these things return, what data type we're working with, what we're trying to do with this mathematical operator. So look over this and let me know if there's anything that you guys think may not work. And you can reference like the line numbers right here. Yeah, Jin is correct. These two variables are all strings. So let's run this. We'll see if that's a correct assessment. Our first number is 10. Second number is 3. But the sum of your two numbers is 103. That doesn't make sense. But then you got to think about that nasty addition syntax. What does this basically do? 10 and 3, right? We already know what that does. You're just combining those two strings together. We don't want that. So in order to get an actual answer that we do want, we're going to have to convert these into integers. And just like with our last example, you can either put it on those input functions directly, or you could put it when you're calling the variable. Either or works. I'm going to do it right here. And once you call the integer, once you turn them all into integers so we can actually add them, then we should get an answer that's suitable. 10 and 3, 13. Well, this is just an addition calculator. What if we wanted to make it a subtraction calculator? Well, add a little subtraction there. 10 and 3, we should get 7. And of course, we can make it whatever we want. We can make it a floor division calculator. Put that there. Do it again. 10, 3. That's a really simple calculator implementation within the context of what we learned, at least. And I actually want to use this to segue into the next thing we're going to talk about, because I feel like we've spent a good amount of time, building projects with mathematical operators and input functions. But if you guys want me to go back and we can build something else with this, then let me know in the chat. Otherwise, something like with what we've written is that every time I want to do a different thing, I have to change this manually, right? If I want to do subtraction, I have to turn this into a subtraction sign. Every time I want to multiply, I have to physically go into the code and then change it into a multiplication sign. It's not that fun. What if I had the code built in place where I could choose what I wanted to do? And that's what we're going to talk about, the idea of binary in programming. And this may get a little bit abstract, especially since I don't have any like images or anything for it. So again, this is one of those sections where if you don't understand, I really ask you to ask that I can go over it again, because it's one of the most important things with coding. But in programming, you've probably heard of the idea of binary, right? Binary programming, your zeros and your ones, right? You're on and you're off. So in programming, we use binary to sort of have this black and white sort of idea, right? Something is either true or something's either false. Something's either black or it's white. It's yes or it's no. And something can exist in two states, right? A true state or a false state. It's a binary state. And this sort of binary idea is called a Boolean, okay? So we have a Boolean. This is something that can either be true or false, right? So let's say 5 is greater than 4, right? That is true. But then if I put 4 is greater than 5, that is false. So you can see that statements like this, right? They fall into two categories, a true category or a false category. And when you look at it that way, you can open the door to sort of logic within your code, okay? So I want to show you guys this control flow idea. So let's say you're going outside, right? You're starting here. You're going to ask yourself, is it raining? Yes or no? True or false? If it is raining, if that's true, then you can sort of determine, do you have an umbrella? True or false? If it's true, then you can go outside and then you end your code. So this is a really simple like implementation of how you could have logic within the code that you write. And it's all based upon this idea of true and false, and then building up on that. So if something is true, do that. Else, do something else. And with that, out of the way, and of course, please, I actually just want to hear from you guys. Does that make sense? This idea of a true and false, of a yes and a no, and of what this sort of control flow diagram shows. Okay, Maria is saying yes. Okay. Okay, cool. So I'm not hearing any no's or anything like that. So I'm going to go ahead then with what we're talking about. So that's a Boolean, right? True or false. Okay. Well, let's go back to my example, actually. 5 is greater than 4, right? This makes sense. We have an integer. But what is this? What is this? Well, in math, that's the greater than sign, right? But in programming, this is something called a comparison operator. That makes sense. You're just comparing these two, right? And you're saying, hey, is 5 greater than 4? Yes or no? So you're just comparing these two things that you're giving that operator. So what are the different comparison operators? Well, of course, you have that greater than, right? But then you have that less than. Then you have less than or equal to, and then you have greater than or equal to, greater than or equal to, and then you have equal to, and then you have not equal to. So I went over that really quickly. So I'll go over that again. These 4 may look familiar. So in math, you have your greater than sign, right? So you're saying, hey, is 5 greater than 4? Yes, right? Then you have your less than sign. So is 4 less than 5? Yes. This sign right here means less than or equal to. So is 4 less than or equal to 5? Yes. Is 5 less than or equal to 5? This is also yes. Because even though it's not less than, it's still equal to, if that makes sense. You're still fulfilling one of those conditions. Because they're basically asking, is it less than or equal to? Well, in this case, it's less than. It's not equal to, but it's still less than. So that means it's true. In this case right here, it's not less than, but it's equal to. So it still works out. Then we have this one right here, and this one means greater than or equal to. So is 6 greater than or equal to 2? Greater than or equal to. Well, it's definitely greater than, so that means the whole thing is true. Is 1 greater than or equal to 1? Well, it's not greater than, but it is equal to, so that makes it true. Then we have our equal to and our not equal to. And that's pretty simple. Is 2 equal to 2? Yes. Is 2 equal to 4? No. 2 equal to 2, that's true. 2 is equal to 4, that's false. And then we have is 2 is not equal to. So is 2 not equal to 2? That's false. 2 is equal to 2. Is 2 not equal to 4? That is true, because 2 and 4 are not the same thing. So these last two get a little dodgy, but these first 4 should be pretty familiar with, if you've done math, you may have seen those there. So that's how you sort of determine, that's how you compare two things, right? And you determine from that comparison, is something true or is that false? Cool. Does that make sense? The comparison operators. And right now, this whole section is going to be a little bit scattered because I touched on Booleans and we're going to touch about comparison operators. But I promise you guys by the end of this lesson, or if you don't have time, the end of next lesson, I'll tie them all together and it'll make sense. So any questions? Or do you guys want me to go over this? Let me know, because if not, we will touch upon Boolean operators. I have the same cup in my house. Yeah, gotta stay hydrated. My voice is getting kind of dry. All good from Maria. Okay, perfect. So we've touched upon our comparison operators. And I'll just leave that there, just in case you guys want to write that down. But if that's fine, we can move on to Boolean operators. Boolean operators. So with those comparison operators, we primarily use them with numbers, right? And in programming, you won't always use them with numbers, but for the sake of the example, we use them with numbers, right? Boolean operators. Well, let's go over what a Boolean is, right? It's that true or that false. True or false. Okay. So how do you chain them together? Well, for that, I have this truth table. Okay. I'm going to zoom in on this. Okay. So let's look at these. We have two conditions, right? Two things, and we want to compare them. I have condition 1 and condition 2. Now, condition 1, we'll go through each case straight across. Condition 1 is false. Condition 2 is false. And then we want to compare them with each other. So the first thing is not x. X is condition 1. So this not keyword is basically going to take your condition and then flip it. Okay? So condition 1 is x. So I just call this x and y instead of condition 1 and 2. But we're starting off with x false. Now, if I add a not to that, then it's going to turn true. So if you say things like not true, that means something's false, right? If something's not false, then it's true. Think about it like that. So x is false, right? So if it's not false, then it has to be true. Okay? And they're not doing one for condition 2, but it's basically the same thing. Okay? So we've sort of gone over what that not does. A not will take something and then flip it. So false becomes true, true becomes false. Not switches it. Now we're going to look at and. Okay? So we're going to say x and y. We know x is false. Y is false. So if two things are false, right? False and false, then the whole thing equates to being false. Okay? Again, please stop me if it doesn't make sense. This is one of the most important things, so I want to make sure you guys have it down. So false and false will give you false. And then we have x or y. Well, both of these things are false, right? X or y. So false or false, that would come out to false. Okay? So that's our first two set of things. So what about when x is false, but then y is true? Well, not x, right? We already know that's just going to flip it. We know x is false. So if we flip false, we get true. Okay? X and y. So we know x is false, y is true. So true and false. True and false gives you false. Because if you're using that and, right, in order for something to be true, both of the things have to be true. So you see right here, see how x is true and y is true? X and y would then be true. However, while x and y, while the and requires both to be true in order for it to be true, the or only requires one of them to be true. So x or y, false or true. Well, we have that one true, so that makes the entire thing true. So it's sort of like what we did with the operator, right? Less than or equal to 5. It's either less than or equal to. That's why I emphasize that or. This is true, right? This whole thing equates to true or equal to. Well, it's not equal to, so that's false. What does a true or false give us? Oops. A true or false, true or false will give us a true. So that's why that statement would make sense. And this is basically the same thing. True, x is true, y is false. Not x. We're just flipping it. So if x is true, not x, so not true, would be false. All right? X and y, true and false. But we know that in order for something to be true with and, they both have to be true. So it'd be false. With or, only one of them has to be true, which we see with the first condition. Finally, what happens when both of them are true? X is true and y is true. Not x, flip it. So not true, that would be false. And then you see x and y. So these are both true. And then finally, we can say true and true is true. X or y, we get true because at least one of them is true. But both of them are true, so it still works anyway. So kind of confusing, but it's things like this that allow you to chain ideas together. So let's say we wanted to have a program. We want a program, and I'm just going to do this abstractly. We're not actually going to code anything with this, but we want a program that does something, right? Only if 4 is less than 5 and 6 is less than 7. That's how we can chain those things together. We have to make sure that both of these come out to true, and if they do, then the code will do something. So that's how that sort of idea of logic is basing itself upon itself. So again, we have our Boolean true or false. Then we have comparison operators, and then we have our Boolean operators. Then we have that's and, not, or. Does that make sense? Last one is a bit confusing, yeah. Okay, do you mean as in like all of the Boolean operators? Because I can go over them again, or do you mean like the or? Is that the one that's confusing? Just the or. Okay. So or, let me think of a good example. Let's do a real world example for or, actually. So let's say I will only go outside if it is sunny or if it is windy, okay? If it's sunny or windy. Well, let's say I look outside and it's a sunny, beautiful day, but there's no wind, right? So it is sunny, right? So that's true. The sunny part of it is true. Or it is windy. Well, I'm looking outside, I'm not seeing any wind. So that means that's false. But I'm still going to go outside, right? Because I'll only go outside if it's sunny or if it's windy. Well, it's sunny, that means I'm still going to go outside. That's how that sort of comes out to being true. Okay, what if I look outside and it's snowing? Well, then both of them are false. Well, I don't want to go if it's snowing. I only want to go if it's sunny or if it's windy. So then this becomes false. What if I look outside and if it's sunny and windy? That's amazing. Those are both of the conditions I want. If it's sunny and it's windy, then I'm definitely going to go outside. That's how this or might play into like a real world example. So with your or, basically the thing to remember is if at least one of them is true, then the whole thing is true. With your and, both of them have to be true, right? So does that make more sense, Maria? Perfect. Awesome. All right. Let's see what we want to go over next. Well, how much time do we have, actually? We have about 24 minutes left. You know what? I think that's okay. I think we have enough time to do what I want to do. So let's put all of this together, right? Let's put our comparison operators, our Boolean operators, and what we know about Booleans together, okay? So now we're going to talk about something called if statements. So think about it like this. Let's go back to our control flow. Here's how a program would look at this. You press play. If it is raining, right? So if it is raining, which is yes, check for umbrella. If there is an umbrella, yes, go outside. So that's how a program might look at a control flow diagram like that. So let's build that. Let's use the tried and tested age example. Make age an integer, right? And what I want to do, I'll bring this down a little bit. I think you guys can see that fine. Is if age is greater than or equal to 18, you in the user they can vote. Okay. So you guys are probably already seeing how that comparison operator is playing in, right? Because we're going to check to see if it's greater than or equal to 18. So here's how we write an if statement. You type if, right? And then we have the expression we want to evaluate. So what is expression? You guys remember how I did 4 is less than 5? This whole thing is what you call an expression. So within the context of the program we want to make, if age is greater than or equal to 18, we want to check, is age greater than or equal to 18? Right? And if that comes out to being true, we want to inform the user they can vote. We can print, you can vote. So we have the if keyword, right? We have the expression, and once you've written out your whole expression, you then put a colon, like that, okay? Press enter, and you see how you've been indented, but indents that in. So if age is greater than or equal to 18, print you can vote. Okay? This sort of indent thing might be confusing you guys. Think of it as a way to sort of organize your code. Python does this automatically. This is actually how Python is made. It's made on the idea of tabs and white spaces to sort of build a hierarchy. So when you look at this code, right, you can instantly tell that this print statement goes under this if. It's not all on like the same line, which make it kind of confusing to read. So that's why it's indented like that. Okay? So everyone okay with that on a syntactical level? So I guess I should go over the formula for creating an if statement. If, and then you have your expression. You don't actually have to have these parentheses. Sorry, these parentheses. But again, it's one of those, readability things. So if age is greater than or equal to 18, that's our expression, and you have that colon. Press enter, then you tab in. Print you can vote. Well, let's think about what this code is going to do. I've given it the variable age, but it's set to 17. I don't think that's going to do anything because it doesn't meet that condition, because it's not going to be true. It's going to be false. So there you go. We get nothing. But if we set this equal to 18 now, then hey, it says you can vote. So what's going on? That first time, right? And that's 17. So it's basically saying, is 17 greater than or equal to 18? Well, it's not. If that's not true, so you can't run this code. So it only continues if it's true. All right. So that's a really simple if statement. Okay. So now let's add on to that. Well, okay, what if I get someone who isn't of the age? Well, I want to inform them that they can't vote, right? So then we have an else. Okay. I'll explain what's going on here. How does this read in plain English? If you're 18 or older, the computer will tell you you can vote. Otherwise, else it'll tell you that you can't vote. So we've run this now. It should say you can't vote because I'm not 18 years or older. This doesn't come out to being true. So then the code will default onto this. Okay? Does that make sense? I'm sure the if statement makes sense, but you might be wondering, hey, why is there no expression with this else, right? Why aren't you checking anything? Well, let's think of else as like the last thing. It's like a default. If nothing else works, it just falls back on the else. So therefore, you don't need to have a condition or an expression for that. Perfect. Okay, I'm glad that makes sense. Okay, so what have we done here? Well, we've used our if and else. Cool. We've used our comparison operators. Cool. Let's chain that with our Boolean operators. Okay. So I'm going to write some code. Actually, let's make a new program. So I'm going to go ahead and get rid of this. Hopefully you guys have it, written and understood. Let's create something that says if the user's age is between the ages of 18 and 24, inform them that they are in the young voting category. Otherwise, inform them that they are not in the young voting category. 18 to 24 is characterized as like the young group of voters. If that doesn't really make sense. Okay. So again, let's start with what we had before. We had our age. And of course, we could make this an input function, but we'll just leave it the way it is right now. I'll say I'm 17 again. Here's the first thing we need to check. If the user's age is between the ages of 18 and 24, well, and, hey, we know what that is. That's a Boolean operator. Okay, so if, what's our first expression going to be? Well, first thing you check if you're between the ages of 18 and 24. That means you have to be either greater than or equal to 18, right? So if age is greater than or equal to 18, and notice that these are uppercase and this is lowercase, these should all be lowercase. Python use all lowercase with these sort of things. But if the age is greater than or equal to 18, and the age also has to be less than or equal to 24, you're creating this sort of like this boundary. Your age has to be between 18 and 24, inclusive, by the way, using that equal than. And if that's true, colon, see how we tab in, print, you are a young voter. Okay, so we've done this first part of our prompt. Second part of the prompt tells us, otherwise, inform them that they are not in the young voting category. Well, we know that's an else, right? Because we don't have to check for anything other than this first thing. Else, print, you are not in the young voter category. All right. So let's run this. I am not in the young voter category. Well, yeah, that makes sense. I'm age 17. So how would Python read this? Well, is 17 greater than or equal to 18? No. Then that's going to be false, right? And then is 17 less than or equal to 24? That is true, right? We have this and between them. And what do we know from our truth table? We know that if something is false and the other thing is true, it still comes out to false. So since this whole thing is false, it doesn't run the code. It only runs if this whole thing comes out to being true. So if that's false, then you automatically default into this else. And from that you type, you are not in the young voter category. Cool. Does that make sense? So at this point now, we've successfully chained together our comparison operators, our Boolean operators. We've learned how to do if statements, and we now know what Booleans are. So does that make sense with everyone? I'll scroll down in case you guys are trying to copy this. So we actually got through most of everything I wanted to go over today. We have about 12 minutes left in class. So if you guys are okay with this, let's go ahead and just do a brief review of everything we talked about in this class. Okay, so we talked about, well, first we started with a review of the last class. So we talked about print statements, f strings, variable naming, all that jazz. You guys remember all that. We talked about our comments, which you guys are probably really familiar with at this point since I've been using them all throughout the lesson. We talked about our mathematical operators, addition, subtraction, division, multiplication, your exponents, full division, and your modulus. We built two little mini projects with that. Remember, we had our years to your 100, and then how many cakes can you make with however many eggs. Then we looked at our input function. Inside of the input function is your prompt, whatever, and then you can save that to a variable as a string. And with that, we made a simple little calculator game, and we also built upon that how many years to your 100 thing. Cool. We talked about Booleans, the idea of something being true, true and false, true or false. So that's something we talked about as well. We talked about those expressions, 5 is greater than 4. And with that, we gave away to our comparison operators. So greater than, less than or equal to, greater than or equal to, not equal to. And we didn't touch on all of them today. Looks like my Repple disconnected again. But we didn't touch on all of them today, but we will definitely continue working with them. And if you guys have any free time, I do encourage you to build some code using what we've learned today. We talked about truth tables, how our and, our or, and our not works. Again, we didn't work with all of them today, but I promise you guys we definitely will in our next lesson. Then, with all of that under our our mastery, we move towards understanding logic, our control flow, how all this stuff sort of fits together, and we use that to create our if statements. I think if statements. Talk about that if and our else. Next class, we'll talk about the else if. Cool. So yeah, Maria asks, when is our next lesson? So the next lesson is going to be tomorrow, 12 p.m. to 1:30 p.m. Same time as this one. I'll be honest with you guys. I started in like the middle of the month, so my stream schedule is not like 100% figured out. By the time July hits, though, I hope to just be streaming Saturday and Sunday. So it's pretty simple, and then keep that consistent for however long I want to. But I just started with Teach, so this like first couple of weeks might be a little bit rocky, and I'm going on vacation. But for this week at least, the next lesson, lesson 3, will be tomorrow, Thursday, June 23rd at 12 p.m. EST. And just like this one, it'll be an hour and 30 minutes long. We're going to finish wrapping up with everything we've touched upon today. So yeah. And of course, since we have 8 minutes left now, let's touch upon some assignments. Let's do a little bit of review, okay? And I want to hear from everyone with this. First question, what are the 2 values a Boolean can hold? We just talked about this. What are the 2 values a Boolean can hold? Captain Board says true, false. True, false. Yep, perfect. You guys even got the capitalization right. Nice. You guys are both correct. Cool. Next question. What are the 3 Boolean operators? Right? Not comparison operators, but Boolean operators. And or not. Perfect. In that case, I'm going to ask, what are the 6 comparison operators? And I don't want you guys to just write the symbols. I want you to write out what they actually are in English, what they actually come out to. So like less than equal to. All 6 of those. What are those comparison operators? Come on, guys. Our comparison operators. I think I might still have it up. There we go. So we have greater than, less than or equal to. Oh, Captain Board, I'm sorry. I didn't see that you had set the answer. Less than, greater than, less than or equal to, greater than or equal to, not equal to. Perfect. Perfect. 100%. Cool. Now we have 4 expressions here. What do they evaluate to? So do they come out to true? Do they come out to false? let me know. Let me just put this right here too so it makes more sense. So there's more logic behind it. So the first one is telling us, is 5 greater than 4? Okay. Second one says, is 3 greater than or equal to 3? The next one says, is 5 greater than 4 and 3 greater than or equal to 3? Okay. Last one asks, 5 is greater than 4 and, oh, we're using not here. So remember, not, let me open up our truth table actually real quick. Not takes your thing and just switches it. So you're going to take this thing and just switch it. Remember, you're working in and then opening it up. So what would you get with these 4 expressions? Perfect. Maria, you hit it. You got it. True, 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 false. 5 is greater than 4. That's true. 3 is greater than or equal to 3. That's true. 5 is greater than 4. So we know that's true. We know 3 is greater than or equal to 3. That's also true. True and true? Well, that's just true. This one might be a little bit more confusing. Last one. 5 is greater than 4. Well, that's true. And we're going to work our way in. 3 is greater than or equal to 3. That's true. Well, something's not true, then it becomes false. True and false. That is false. And Maria, you got it right. And it looks like you guys are having a pretty good grasp of everything we've covered so far, which is awesome. We have 4 minutes left. So if you guys have any questions for me, not just ones that pertain to this course, but like other things like what we might talk about later in the course, I'll be happy to answer it. But if not, if there are no questions or there are no concerns, otherwise I DM'd you on Instagram about the previous class, if you're going to be posting that on YouTube or not. I haven't gotten around to it yet, but if you head over to teach.tv, you should be able to find under my profile this recorded class, and then you'll be able to watch it. So I can actually go ahead and post my profile link in chat. Actually, I don't think I can, but that's how you can access that. I also ask if you guys need any additional help, any counseling or whatever, you should be able to head over to my teach.tv profile and you can find all of my links. And then you can use those to contact me if you would like to do so. I also have a Discord. You can find the links through my Instagram and whatnot. But I'm not seeing any other questions. You guys did great today. I really appreciate the support and everything that I've been getting for this course. We don't have as many people as we did when we first in our first lesson, but I'm glad that the folks who stuck around have a good understanding of what's going on. And this lesson, its recording will also be live on Teach soon. It takes a while for it to like load up. But yeah, thank you for your hard work, guys. I really appreciate it. What would you recommend the best way to get in contact with you? Do you prefer one over the other? Well, if you head over to profile, you can go to this Instagram profile and you can DM me here. I don't mind. Or you can click this link tree and then use that to find my Discord server. So I guess if I had ways that I really preferred, Discord server and Instagram DMs, those both are okay with me. I don't really mind, guys. If you have good questions, I'm always willing to answer them. So without any further ado, I'm going to go ahead and close up the class. Again, thank you guys so much for your patience, everything, and take care of yourselves. Have a nice day.